and welcome. The following video is a zero-touch deployment demonstration utilizing Cisco 4500 IE4000 switches in a lab environment. The video will demonstrate the ability for these switches to auto-provision themselves into the network, and we're going to walk through each step of that, how that works, and how you would do this in an actual production environment or on an initial build at a site location. In order to deploy a site, we need some information about that site before we can begin. We've decided to put that information in a simple CSV format, something that could be used in Excel and anyone can fill out. In this case, we try to limit the amount of information we need about the site because we know a lot of the information before it gets deployed. Most of these sites are similar. In our case, we're asking for the site name. In our case, we made up Washington, DC. The type of switches we're going to deploy, whether they be 4500 or 4000, those could be any number of different types. The MAC address of those switches, that's the actual MAC of the switch itself, as well as the management IP, subnet for the VLAN that you're going to deploy, in your case a private VLAN that you would deploy, and then as well as a code level that those switches should be at when we actually bring them into the network, because we're going to upgrade them or downgrade them, whatever makes sense. Finally, we need the package name. What is that package name for that code that we're going to go ahead and deploy? We need to know that in order to check to make sure it's there. Here we are sitting in front of a IE4000. In this case, we can see here that the version of the code is 15.2.4 We're going to either upgrade or downgrade that based on the CSV file that we actually have. In this case, our switch is completely blank. It's been write erased. We can see that the host name is all default. It's all set to switch. It's been through a write erase and rebooted as if it came straight out of the factory. We can see the Ethernet is all completely wiped out, no VLANs. Here we have a Cisco 4500, just like you would. Here we can see that the version of code is 3.11.02e, which we are going to potentially downgrade or upgrade depending on what that CSV input we gave. In the same vein as the IE4000, we can look at the running config. We see here there's absolutely nothing on this switch. It's completely basic, straight out of a write erase, as if it came straight out of the factory. There's nothing unique about this. At this point, we're going to go ahead and look at the deployer. The deployer could be a laptop, a server, whatever. In our case, we were talking about this being a laptop that's not connected to anything, except for the switches we're deploying. We have an auto provision start.py, that's the script that actually runs to start this whole thing. And then we have two CSVs, a downgrade and upgrade. That's just so we could go up and down as we wanted. We're going to go look at the downgrade file. As we can see, the downgrade file, it has the code information. We can see we're at 3.08.10, so that means we're actually going to downgrade these switches. We're at 3.08.11 or 3.11, I believe. We're going to look at the version here. We can see here we're at 15.2.4 and down here we're asking it to go to 15.2.4 to line up with what we want at this site location. We look at this, we're at 03.08.10. We look at the version, we're at 03.11. So we're also going to downgrade this one as well. Here we can see that we've already moved those packages onto our TFTP server. We see here that's our root. This is the same server that we actually are doing the deployer from. This is just another console into it. We can see we have the two packages that were required by that CSV file. Those packages are already sitting there in our TFTP root. If not, we'll show later that it would actually check for that and it would actually stop the script before it would let you continue and ask you to move it to the right place. At this point, we're going to start the auto provisioner. The auto provisioner is a small Python package. It's part of the Ansible packages. And then we're going to give that config file, it has a config file switch that we pick that downgrade CSV that we just looked at. It's going to ingest that, and then we're going to walk through the steps that what it does with that ingestion and what actually happens when this occurs. At this point, the actual auto provision is already done. That's it. That's about 1 second for it to actually begin. Everything is ready to actually deploy these switches at this point. But let's walk through each and every piece of this. We see here we ran the downgrade in just that CSV file. First thing it does, look at what type of switches. It says, hey, I found 2 core switches being 4500 switches, 4 IE switches. If that's correct, we continue on. It's just giving the user some information. At that point, we create our config files. These are custom built and dynamic. Well, what they are is dynamically built based off that information we got from the CSV. They create a directory based on the date name. We build it right where you're running the script from. We add some temporary IP addresses. This is so we can actually run some scripts against it and make sure SSH is actually working. These would be removed later. At that point, we created the actual configuration files. These are the switch configuration files that will be downloaded by the switch through the Cisco auto install process. They will go out and reach out using DHCP and TFTP. They're going to find the correct config, and we're going to tell it which is the correct config. Through this script, we actually build a DHCP file that tells it what the right config is. We see here we have an auto install DHCP. It's telling the IE4000 which package of code it should be looking for. The final piece here in building these is to create some Ansible scripts. We're using Ansible to upgrade the 4500 switches. They don't have an auto install process where they upgrade themselves or downgrade themselves correctly. So we're actually writing some custom Ansible here, and it custom builds these scripts based on the information, again, that was in that CSV file. It tells it where it should be upgrading to. Later on, it's going to check to make sure it's at the right version. If it's not, Ansible will actually upgrade it for us. Next part, go ahead and look. We got a DHCP file. It's going to go ahead and look at your local config, whether that's a server, a laptop, whatever. It's going to find the IP address of your local server or laptop, whatever it may be, VM, doesn't really matter. This runs on any Linux, RHEL, whatever. It sees that this is the host name, that's our host name, as well as our IP address. And we go ahead and create a DHCP file that is custom built for these switches that we're trying to load up. Final part is going to check a couple of things to make sure everything's ready to actually start this process. We're going to look to make sure DHCP is actually there. We see here that etc DHCP exists, so we're going to go ahead and move forward. If it didn't, we would actually stop the script. Finally, we check, is there a TFTP? We believe that's the correct TFTP route, and we're going to go ahead and move forward. Next part, we're going to go ahead and make sure that boot code is in that DFTP. We got that from the CSV file. We need to make sure that those files actually exist in that TFTP, because when we go ahead and try to upgrade, they better be there. Otherwise, this whole process will fail. So once all that's in place, we know that everything's ready to go. We let the user or administrator know, hey, everything's ready to go. We're going to start copying the files into the appropriate locations. So for example, we're going to move those config files to that TFTP route. We're going to move every config file that we need for every switch in that CSV. And before, you could see that we just saw in there just the actual code files, but now we actually have all those config files as well as that auto install DHCP file. So all that gets moved appropriately by the script. We also move around those Ansible configuration files, or the Ansible script files, move them in the right place so that everything's ready to run once once you actually start rebooting the switches, and we'll walk through how that process actually works. So once all that's in place, all the files are in the right place, we go ahead and we're going to start DHCP. We see that the service was inactive. We can see now the service is actually running. We're just showing you some standard out. It's just showing you what actually occurs. And then we print to the screen that DHCP has started to let the user know everything that's happening. Final part is TFTP is about to start. We need to start our TFTP. In our case, what's going to happen is TFTP, it's going to basically just have a log running all the time, and you're going to watch everything that occurs. So if you're the user, you're just watching the screen, and it's just pumping out what files are being downloaded, are things upgrading. You're going to kind of see everything from one console. It's telling you when you're done, hit Control-C, it'll walk you out of that script, and it'll actually give you an output about what happened. And then in order to start this, we have to write erase and reboot these switches. So we're going to go ahead and do that now. Here you see we're up here on the IE4000. We wrote a write erase. which means erase everything in the running config and startup config. We're gonna start from nothing. We're gonna start from a base switch. Now we already know it's a base switch, but just to prove that this is absolutely going from 0 to fully built configuration with the correct code on it, we're gonna go ahead and do it again. We're gonna reload, meaning reboot the IE4000, and we're gonna reboot the 4500. Now that the IE4000 is rebooted, we can see here that the auto install has started. So it read that auto install file and realized, hey, we could see here in the log that it actually downloaded that auto install, looked inside of it, and found that tar file that we needed to actually upgrade. Now that the auto install is complete, it actually has downloaded that file, that upgrade file, and it's starting to delete the old image and upgrading to the image that we gave it. All this again was from the CSV file. So at this point, it's actually pulled it off the TFTP. We can see down here that you actually have the tar file. We can see that the tar file was actually downloaded. We can see up on the console of the switch that it is started moving forward. Over here, the 4500 is begun. It has saw from the auto install file that it also has downloaded its configuration. Again, it doesn't have an install file, it has just a configuration file that it does automatically. In this case, what we're doing is we see a first download, and we'll go ahead and download that config, and then we're gonna say, hey, we recognize you downloaded the config for the first time. Let's go ahead and get ready for the Ansible script to start. We'll wait 2 minutes, and it's gonna begin. Here we see that the 2 minutes has passed, we're accelerating. We see that we have Ansible script has started. We can see the upgrade has started. It's checking the current code level of that 4500. Sees that the code level isn't up at the correct version, and we're going to go ahead and we can walk through each step of this. So it tests through something called facts. It sees that what code level's on it, what host we're talking to. Then we make sure that TFTP is going to work on this. Then we start copying the correct image down onto Flash. We see as soon as we say that, we can see that it downloaded that bin. Over here, we can see that the user Ansible has just logged into VTY0. So that script is actually doing login, logouts, and actually configuring that switch. We see it downloaded the actual correct config as well. At this point, we can also see that the IE4000 has downloaded its config, but we recognize that that's not a 4500, or it's going to install itself through auto install, so we aren't going to upgrade that one. We're not going to start any Ansible scripts. Over here, we see that Ansible has downloaded the config. We see it set the boot system Flash to the new version of code, and we're going to go ahead and reboot it. This is all through an Ansible script that custom writes, again, each time through the CSV. At this point, the IE4000 has upgraded itself. We saw it go pretty fast here, but it upgraded itself. Then auto install has started again. It starts a second auto install. In this case, what's going to happen is it actually downloads it again, and what happens is it downloads it a second time, make sure it's the right version. If it is, it just leaves it alone, doesn't do anything. And then what it's going to do is start the auto configuration. Auto configuration is actually now run, so we see here it's actually set up passwords. You can see here that the actual file has downloaded the correct file for this switch. And so it's fully configured at this point. This switch is fully done. That's an IE4000. Actual time to do that is about 10 to 15 minutes, maybe less. At this point, Ansible script has continued moving forward. We see files coming down. We see here we're going to wait a minute. The reason we're waiting a minute is we waited for SSH to come up. Once we saw SSH came up, we're going to wait 1 minute to make sure that everything is ready to go. At that point, we log back into the switch. We check to make sure it's the right version. We see it did. Our script recognizes that it did have a successful Ansible script and lets the user know. At this point, both switches are fully configured. The actual time we've accelerated, but the time to actually do this is about 15 or so minutes in total. Here we're going to log into the IE4000. Part of the reason we can see here is that the switch has downgraded itself to the correct version that we had in the CSV. We go over the 4500. Again, we see the switch went from 311 to 308, downgraded itself automatically. But more than just an upgrade or downgrade, we want to make sure these configurations are actually custom built for this site and all correctly installed. Here we're going to show you the running config. We saw before there's nothing on it. Now we have users. Now we have crypto keys. We have keys. We've rolled a new SSH key onto this. As we look, we built VLAN 100. In our case, it's a private VLAN, so we're deploying private VLANs, isolated VLANs. We built our port channel up to the uplink to our 4500. We went ahead and set up those ports, and we have a full port channel built. At this point, we also configured every port for the camera or whatever you're going to run against these ports and set it up for the private VLAN appropriately. We set up the VLAN 10. We went ahead and set up VLAN 100, and that VLAN is the one we got from the CSV. VLAN 10 was actually a management VLAN that's temporary. So now we'll go to the 4500. We can see we have an enable password on this one, for example. That was configured. Now we see we booted off this 30810. 30810 is the code we said. Users are here again. So now we have usernames on here. You can see here the port channel was built, so the port channel is done. And we built a port channel for all 4 of those IE4000s we had in that CSV. So we knew that there were 4, and we built 4 port channels. We also set all the appropriate switch ports to be able to do LACP to each one of those IE4000s when they're plugged in. We shut all the other ports down. We know that for security reasons, we don't want those ports up if they're anything that isn't supposed to be plugged in. VLAN 100 is configured. We're at .2 now. So now our private VLAN is ready and everything has been created. We're done at this point. These switches are ready to go. We're going to go ahead and look at the port channel 1 just to show that we actually established an LACP port channel. We can see here that we have a we have a 2 gig port channel ready, up and running. At this point, we're going to close that script. We're done auto provisioning. At this point, what happens is it's actually going to close that TFTP service. We don't want it running unless we're ready to deploy. We also close DHCP. You can see here it gives us a log showing that it died. Finally, what we do is we go ahead and give you the final statistics of what actually occurred, and we can see that which switches actually downloaded and which ones did not. So if the user wanted to run it again, they could at this point.